Hey, what's up, dude?
Hey, what's up?
Not much, I was just in class.
Yeah?
Katy Perry again?
Yeah, of course.
Well, what are you up to?
Well, I got this brilliant plan. You want to hear it?
Why not?
So, look, Gila monsters, they like to eat mice, and I really like Gila monsters, so I want Gila monsters to be everywhere. I think it would be awesome. So, what I did is I went online, and I'm going to order a bunch of live mice and release them into the desert, and that way we're going to have a lot more Gila monsters because there's a lot more food.
Christian.
What? It's a brilliant plan, I know.
Where to start? Christian, do you know what happens when people muck with ecosystems this way?
I know what happens when I mess with the ecosystems this way.
Dude, why don't you get a Gila monster? It'd be a better plan.
This is way more fun. We have lots of Gila monsters for everyone to enjoy.
Alright, look. Do you know how food webs work?
Yeah, I add more food, there's more Gila monsters, equals more awesomeness.
Alright, dude. Look, I gotta take you there one more time.
Oh, back to the...
I'm sorry, we got to. This is serious. Trust me.
Alright.
What? Mike, where are we? Well, not again.
Yep, this is the only place I can tell you the story correctly.
I was in the middle of something really important. I'm trying to save Gila monsters.
Just take a few minutes with me.
All right, go
Listen, there were a lot of other people that had similar crazy ideas to you. I'm just going to take a species out or put a species in and hope that everything's going to work out the way I want. That's not how nature rolls.
ahead. I know it's going to work out like that.
No. Things are very complex. Think about this sea otter story I was telling you about.
Okay.
Okay, so around the turn of the century, people were very concerned because sea otters were eating fish, and people like fish too. So they figured, all right, well, we'll just go in and we'll kill all the sea otters, and then we'll have plenty of fish, right? Take out the predator, we should have an increase in the prey.
Makes perfect sense to me.
Sure, but that's because you're using a very simple model of the world called a food chain. So in a food chain, you might have some primary producer like phytoplankton, which does photosynthesis and gets its energy from the sun. And then you would have some consumer like zooplankton, those little micro crustaceans and things that are in the ocean, and they would eat the phytoplankton. Then you'd have some carnivore like fish eat the zooplankton, and then finally a secondary carnivore like otters. And you would think to yourself, all right, well, otters are at the top. We take out the otters, and everything underneath does better.
Yeah.
Right?
Like I said, makes perfect sense.
Well, it turns out the world isn't a food chain. The world is a food web, and that's a much more complicated model. So here's what happened when they took out the otters. They started trapping and shooting otters, right?
Mm-hmm.
Otters not doing well then.
Right, the otters must not have liked that.
No, they were not happy at all about that. As it turns out, though, when the otters went down, the fish didn't go up. The fish populations also started crashing.
Why is that?
That's crazy, right? It's not at all what you would expect.
No.
That's where the food web comes in. The food web is different from a food chain. Here's a food chain. Again, just to summarize, we've got primary producers at the bottom. We've got herbivores that eat them. We've got a carnivore that eats herbivores, and we've got a secondary carnivore that eats the first group of carnivores.
So the primary producers, like maybe grass, for example.
Yeah,
or
grass, or in this case,
algae, or
yeah,
phytoplankton.
macroalgae living in the ocean, or
Right.
phytoplankton.
Okay, so the herbivores in this case are like the zooplankton.
Yeah.
Right? Okay. Carnivore. The first carnivore could be fish.
Yep.
And then the next one is the otter.
That's correct.
Okay.
So again, simple model, right? Very linear. We take out the top, and everything underneath does better.
Okay.
All right?
Got it.
Unfortunately, the world isn't like that. If you take out the otters, the fish didn't do better. So clearly, these boxes are capturing a whole bunch of stuff that in the wrong way. In other words, we're ignoring a bunch of side chains in the food web by collapsing them all together into one box called herbivores or one box called carnivores. And that can be really important. Just take an example from an experiment that was done by a guy named Bob Payne, who worked on the northwestern coast of the United States. That's where all those rocky shorelines are.
Yeah.
Right? So this guy was studying a very rich community of species, maybe about 30 species or so living on that rocky shore. All right? But if you were to map out how they interact with one another, you could see at the very top of that community was a starfish of the genus Pisaster. And those starfish were a top predator. They eat a whole bunch of things. Some of the things they eat, for example, are mussels from the genus Mytilus.
Okay.
right? These mussels you attach to the rocky shore, and they filter feed there, right? And the starfish basically climb on top of them, pry them open, and then eat them.
Wow, okay.
Yeah. So not good if you're mitoless, right? There's other things that the starfish eat. They eat mitella, which are barnacles, and the barnacles are also those little hard things that attach to the rocky shore.
Right, okay.
And you can see a picture of one now. But if you think about what's eating the mussels and the barnacles, it was also a little more complex because there were multiple predators doing this. So there were some snails, like of the genus Nucella. Those snails would then crawl around on the shore eating both a bunch of different things. They were eating mitella, which are barnacles, and they were also eating balanus, which are barnacles. Now, the thing is, when you have all these interactions, complicated things can happen.
So hold on, I'm a little confused for a second. Just want to understand this graph. So the black lines represent something eating something else, so a predator.
Right. So
Okay.
the starfish eating mitella.
Eating the mussels, okay, or eating the
barnacles.
barnacles, right? Okay. What are these red lines? So replaces. You said something about complex.
So it's even more complicated than just predator-prey interactions. There's also competition between species, and that can make a big difference.
Okay.
Especially when you're taking species out or putting species into a community. Well, let's just look at a simple example between that mussel we talked about, Mytilus, and that barnacle, Mitella. Now, those two species compete for food. They
Right.
both are filter feeders, meaning they take small little particles out of the ocean currents. So they also compete for space because they both use space on that rocky shore in order to get access to that current.
Mm-hmm.
If you were to let those two go in isolation, you would find out that the mussel is a much more dominant competitor. It will outcompete the barnacles.
Okay.
And so the barnacles would eventually disappear.
So you said they did an experiment with the piezasters. So
Yeah,
what
so
did they do?
let's what do you think would happen now, given these interactions of predation and competition and this complicated web? What if I were to take out the starfish? What do you think would happen?
Well, since the starfish eats, for example, the mussels or the barnacles, I would expect, maybe the mussels, for example, their population might go up.
That's correct.
Okay, makes sense.
But what about the competition now? Factor that in as well.
Oh, okay, yeah. So maybe the mussels, if there's more mussels, maybe you said they outcompete the mitella, the
Right.
barnacles. So maybe the mussels increase, the barnacles decrease in terms of their population.
That's right. And in fact, a whole bunch of other things happened as well because this is a very rich food web. And as a result, when this researcher took out the starfish on some plots, then half the diversity, half the species disappeared.
So the starfish are pretty important.
They're very important. And in fact,
Okay.
they're called a keystone species. And we know that it was a starfish because he had control plots where he didn't remove the starfish, and those plots, the biodiversity remained intact.
So we're seeing some direct effects of the starfish, for example, on mussel populations.
That's
the
right. We
Mytilus.
have your typical food chain kind of things going on. We've got starfish eating the mussels and eating the barnacles, and they're negatively affected. And those are direct effects of one species on another.
But maybe there's what's the word? Indirect effect between, removing the starfish on the mitella, the barnacle population.
Yeah, that's a good way of thinking about it. So starfish indirectly affect lots of species as well, even ones they don't eat. So they indirectly affect mitella because they reduce Mytilus,
Okay.
which then allows mitella to grow without competition. So starfish in this case have direct and indirect effects on mitella. Direct effects of predation and indirect effects by reducing the amount of its competitor.
I think it would help if I saw a definition.
Yeah, I think so too. So let's go with this. For a direct effect, we have a change in the abundance of a species caused by an interaction with another species.
Okay.
So prey decrease because their predator eat them.
Okay.
All right?
Makes sense.
And for an indirect effect, we have a change in the abundance of a species caused by an interaction between two other species. So we need at least 3 species.
Okay.
So in this case, the barnacles go up because of the predation between the starfish and the
On
mussels.
the mussels. Okay. Yeah, that makes sense. So
Got
this
it?
this is all about starfish and mussels and barnacles. But what about the otters? They were really cute. I want to hear more about them.
Right. This is really important for the otters because all of that stuff was indirect effects. So go back to the otters and remember, we had otters eating fish and that was the problem.
Right.
But otters eat more than fish. Otters also eat purple sea urchins.
Okay. Purple sea urchins.
They
All
love
right.
to eat purple sea urchins.
What do they look like?
Well, they look like this.
Okay.
And just as it turns out, purple sea urchins also like to eat things, and they eat kelp. Kelp are these really big sort of green algae that grow, macroalgae that grow in the water, and they're a wonderful place for fish to develop. So you can imagine, you take away sea otters aren't eating purple sea urchins. Purple sea urchins explode, the population of purple sea urchins then grazes away all the kelp,
Right.
and now the kelp's gone. And guess what? There aren't any good places for baby fish to develop, because that's where they develop, in kelp gardens.
So the fish populations go down because of that.
That's right.
Oh.
So it's a whole series of indirect effects that weren't quite obvious from just thinking about that food chain.
Okay. So if I stop, trapping otters and removing them, will it start to turn back to normal? Will the environment start to turn back to normal?
Turns out you're right. We no longer do that. We no longer kill otters. They're protected. And as a consequence, otters have rebounded in lots of places. And where otters have come back, sea urchins have gone down. And then kelp has also grown back. And now fish populations are healthier.
So everyone lives happily ever after.
Yeah, but remember, there's a lot of stuff going on, and it's not always a happy story.
Of course not.
In some places, people have overfished so much that other things that eat fish have had to turn to new prey. For example, killer whales. Killer whales like to eat fish too, and if we overfish, killer whales in some places have started to eat otters. So now, while we're not killing otters, killer whales are killing otters, and then the whole thing is starting over again someplace.
So you're saying it's pretty complicated.
It's very complicated, and you shouldn't go mucking around with communities.
I think I have an order to cancel. I'll be right back.
You better get to it.
Yeah.
See you next time.